Alex, I used to think the only way to slow down a drill press was to play a game of musical chairs with greasy rubber belts while the motor was still humming. I've probably spent a cumulative 3 weeks of my life moving pulleys around just to keep from smoking a Forstner bit.
Well, I've seen your hands after those musical chairs sessions, usually more grease than skin. But now you're obsessed with these little gray boxes. It's like you've traded your mechanical soul for a silicone one.
It's not a betrayal, it's an evolution. It's like going from a horse and buggy to a car where you can actually choose the gear while you're driving. That little box you're holding, the variable frequency drive, is basically the brain the Industrial Revolution forgot to give us.
Okay, I get the magic box appeal. But for those of us who aren't electrical wizards, what is it actually doing? Because if I plug a motor into the wall, it just goes. It's a simple relationship. Why are we inviting a middleman to the party?
Because the wall is a stubborn beast. In the US, the grid gives you 60 cycles of alternating current every second, 60 hertz. Most induction motors are like old school soldiers. They march at exactly the pace the drum beats. If the drum beats at 60 hertz, a two-pole motor is going to try to hit 3,600 RPM. It doesn't care if you're trying to stir a delicate finish or drill through a piece of hardened tool steel, it's going full tilt.
Right, so the VFD is the guy who tells the drummer to slow down?
Exactly. It takes that rigid AC power, tears it down into DC, basically flatlines it, and then rebuilds it into a new AC signal at whatever frequency you want. If you want 20 hertz, you get a slow, powerful crawl. If you want to overclock it to 70 hertz, the motor starts screaming like a jet engine.
I saw a video from the engineering mindset about this. They mentioned something called a rectifier and an inverter. Is that the tearing down and rebuilding part?
Spot on. The rectifier is the intake. It takes that wavy AC and pushes it through diodes until it's a big, steady pool of DC energy in the DC bus. Think of the DC bus like a water tower. It stores the pressure. Then the inverter, the real artist of the group, uses these things called IGBTs, which are basically high-speed light switches, to flick that power on and off so fast, it tricks the motor into thinking it's seeing a smooth AC wave.
High-speed light switches. That sounds like a recipe for a very expensive fire if you wire it wrong.
Oh, I've smelled the magic smoke more times than I'd like to admit. My first VFD install, I treated the ground wire like an afterthought. I figured, it's just a safety thing, right? Wrong. These drives create a lot of electrical noise. I turned the lathe on and my shop radio started screaming, and the digital readout on my calipers began counting backwards. It was like a poltergeist moved into the tool chest.
So, aside from avoiding ghost calipers, why shouldn't I just use a mechanical speed reducer? You know, a gearbox? It's simpler. No magic smoke involved.
Gearboxes are great for pure, raw grunt, but they're honest-to-God anchors. They're heavy, they leak oil eventually, and they have one speed setting, whatever you bought. A VFD gives you a ramp. If I'm spinning a 300-pound bull blank on the lathe, I don't want it to jump from 0 to 600 RPM in a heartbeat. That's how you end up with a bowl-shaped hole in your workshop wall.
I remember that hole. You told the neighbors a stray meteor hit the garage.
It was a very localized astronomical event, but with a VFD, I can set the acceleration time to 10 seconds. The motor gently wakes up, whispers to the wood, and slowly brings it up to speed. Same for deceleration. You can stop a massive spinning mass without it unscrewing the chuck and launching it at your shins.
Okay, let's talk shop. If I'm a maker and I've got a three-phase motor I found at a scrapyard, but I only have single-phase power in my garage, you know, the standard plug, is this my golden ticket?
That is exactly the killer app for us small shop guys. Most heavy-duty industrial gear, the stuff that's built to last a century, runs on three-phase power. Most homes don't have that. A lot of VFDs can take your 220V single-phase house power and phase convert it. It creates that third leg of power digitally. It's like finding a way to run a semi-truck on 8A batteries, except it actually works.
But there's a catch, right? I'm looking at these parameters in the manual. VHS control, sensorless vector. It looks like a math textbook. Which one do I actually need to care about?
For most of us, VHAZ is the bread and butter. It just keeps the ratio of voltage to frequency steady. It's perfect for fans or pumps. But if you're doing something where you need massive torque at really low speeds, like a metal lathe taking a heavy cut at 50 RPM, you want sensorless vector control. It's basically the drive feeling the motor's resistance and pumping in extra juice to keep it from stalling. It's like a car's cruise control. that knows you're hitting a hill before the speed even drops.
Wait, I've heard people say that running a motor too slow with a VFD can actually kill it. Is that just shop talk, or is the motor actually going to melt?
No, that's a real danger zone. Standard motors have a fan attached to the shaft. If you slow the motor down to 10% speed, that fan is barely moving air, but the motor is still working hard, generating heat. You'll cook the insulation on the windings. If you're going to run slow all day, you need a constant torque-rated motor or an external cooling fan that doesn't care how fast the shaft is turning.
So it's not just plug and play, you actually have to think about the thermal physics.
Woodworking is 10% cutting and 90% stopping things from catching fire or flying away.
Let's talk about the integration side. You're big on control panel design lately. I see you've got these little potentiometers and switches mounted on your machines instead of just poking the buttons on the VFD itself. Why the extra work?
Because the VFD is a delicate piece of electronics, and my hands are usually covered in sawdust, metal chips, or some mystery adhesive. You don't want to be stabbing at a tiny plastic button on the drive while a piece of mahogany is vibrating off your workbench. I remote mount a big, beefy e-stop and a nice, chunky dial.
Plus, it makes you look like a mad scientist.
Well, there's a certain satisfaction in turning a dial and hearing a 5 horsepower motor growl in response. But there's a safety logic too. You can wire your VFD to a PLC, a programmable logic controller, so the machine knows not to start if the guard is open. Or it can automatically slow down the feed rate if the motor starts pulling too many amps.
Speaking of amps, what's the biggest mistake you see people make when they're sizing these things? Is it as simple as get a 2 HP drive for a 2 HP motor?
You'd think so, but that's a trap. You always want to look at the amperage rating, not just the horsepower. Some motors are heavy duty and pull more current than a cheap motor with the same HP sticker. I usually tell people to upsize the drive by 1 step if they're running on single-phase input. It gives the internal components some breathing room. It's like buying a truck that can tow 10,000 pounds when you only have a 5,000-pound trailer. It just runs cooler and lasts longer.
Okay, troubleshooting time. The screen on the VFD is flashing OC or OV. I'm assuming that doesn't stand for of course or oh very nice.
Usually it's overcurrent or overvoltage. Overcurrent often means you're trying to ask the motor to do more than it's physically capable of, like taking a 1/4-inch cut in stainless steel with a dull bit. Overvoltage is trickier. That usually happens during deceleration. If you try to stop a massive heavy flywheel too fast, the motor actually turns into a generator and sends power back to the VFD. The VFD gets overwhelmed and trips out to save its own skin.
So what's the fix? Just slow down the stop time?
You can lengthen the ramp, or you can install a braking resistor. It's basically a big heating element that takes that excess energy and turns it into heat. It's like the engine brake on a semi-truck.
It sounds like the VFD is the ultimate bridge between I have a tool and I have a precision instrument.
That's the best way to put it. It's about control. Before I had these, I was always fighting the machine. I was adapting my work to the speed of the motor. Now the motor adapts to the work. If the wood is burning, I dial it down. If the metal is chattering, I find that sweet spot frequency where the vibration disappears. It's like finding the perfect tune on a guitar.
And the takeaway for everyone listening? Don't be afraid of the gray box, but don't treat it like a toaster.
Precisely. Read the manual, and I mean the whole manual, not just the quick start guide. Respect the electricity. If you're not sure about the grounding, find someone who is. Because when a VFD is set up right, it's the quietest, most loyal partner you'll ever have in the shop. But if you disrespect it, it has a very expensive way of telling you no.
On that note, I think I'll stay on the stool while you flip the breaker on that new build.
Fair enough. Next time, maybe we'll talk about why my shop vac tried to become a jet engine when I hooked it up to the wrong circuit.
I can't wait for that disaster story. Thanks for the deep dive, Tiger.
Anytime. Now let's see if this thing actually spins.